Okay, kids, we're back today. We're in section 10.3, so chapter 10, section 3, and we're going to talk about something called the ray model of light. And the key word here is model. It's a way of thinking about light that helps us understand it. That's what it is. So in the ray model of light, light is represented as straight lines called rays. You can see them here, which show the direction that light travels. Ray diagrams, so another very important word, rays and ray diagrams that are in a different color, are drawings that show the path that light travels after it leaves its source. So the flashlight is the source, and here are the light rays that leave the source. Some of them miss the person's face and just keep on going. Some hit the person's face, their eye in particular. And each arrow ends with an arrow to indicate the direction of travel. And here's some examples of that. So here we've moved the person further away, and you notice right here we had 3 light rays hitting right smack dab in the eye, but since we moved the flashlight away or the person stepped away, it doesn't matter, they're further apart. There's less light rays showing it. So not only do light rays work well as a model for showing us the direction and the path of the light ray, they also can show us how much light is there to begin with. So it's a pretty useful way of thinking about it. Now, as I said, I hope you watched the video from before. It'll make this lesson a lot easier. So eventually light hits a material. And when light hits a material, 3 things can occur. The light can go through it, which we call transmit. The light can stay within it, it's absorbed, or the light rays bounce off of it, called reflection, like a basketball off the basketball court. So there are 3 categories of materials when we talk about what light, how light interacts with matter. One type of material is called transparent, such as clear glass or plastic, and they really let the light go through. They transmit it very well. They absorb and reflect very small amounts of light. That's why you can see through a window pane. Translucent materials. Some materials transmit some light, but not enough to see through the material clearly. I hope you watched the video because they had some good examples in the video of what it meant to be translucent. A frosted window pane is a good example of translucent material. Some light can pass through, but you cannot see on the other side of the frosted glass. Way back in our wonderful school, West Lane, some of the windows in the bathrooms are frosted. So they let light through so you can get daylight in, but no one can see you doing your business there, washing your hands, what have you, in the bathroom. So that's translucent. Opaque. Opaque. It is not pronounced opaque. Opaque. Objects absorb and reflect light, but they don't transmit it, like a brick wall. All right. And I've added this little diagram to help us recap that. Transparent. Most light travels through. We call that mostly transmission. Very little absorption. Very little reflection. It looks like I missed a word here. Let me fix that. Most light. Let me sneak a word in here. Most light travels through, so that's transparent. Translucent, some light passes through, so a little bit of transmission, a little bit absorption, a little bit reflection. But even when the light goes through, see how the light doesn't keep its direction? It's scattered. And then we have opaque. Nothing gets through. It's mostly absorbed and reflected. Nothing gets through. So those are the 3 types of materials. And the 3 things light can do is transmission, absorption, reflection. And depending on how much of each happens, you will classify a material as transparent, translucent, or opaque. Now, one of the best proofs that we can have that light travels in a straight line is shadows. Shadows really show that light travels in a straight line. So here is a source of light, Some of the light hits it, and here's the first light ray that just sneaks by at the top. Here's the first light ray that just sneaks by at the bottom. And that is good evidence, the production of a shadow, that light travels in a straight line. Right? Same thing here, but at a slightly different angle, doesn't matter. The light rays are either absorbed, don't get through, or some get past it, the object, and you'll get a shadow. Now it can get more complicated because this is what we call a point source of light. So there you just draw two lines. There's the opaque object. There's the dark shadow called the umbra. But most things in the world are not a point. There's actually a size to them. So what you do is you take the top point, draw light ray from here. Look at this light ray right here. It goes from the top past the top of the object. Then this light ray goes from the top just past the bottom of the object. We do the same thing with the bottom to help us understand this large object. So from the bottom, a light ray just sneaks past the top of the object, and this light ray just sneaks past the bottom of the object. So what you get is you get the full shadow, the dark shadow in the middle, the umbra, that's the name for it, like an umbrella. And then on the outskirts, you get some light getting past it, right? And we call this penumbra, because up here, you'll get light from the top of the light source, but not from the bottom. And similarly down here, you'll get light from the bottom of the source, but not the top. So it's a lighter shadow, penumbra. When you get no light getting through, like in here or in here, it's umbra. So that's what we have here. You can use ray diagrams to help you explain the size and location of shadows and why some shadows are sharp and well defined while other shadows have less distinct edges, the penumbra. A shadow occurs when an opaque object blocks the direct light from a light source. A ray diagram, see, we're using what we just learned, illustrates how the size of the shadow depends on the size of the object blocking the light and the distance from the light source. Right? So where is the object? How big is the object? How big is the light source? It's all going to have an effect on the shadow. So umbra, a new word for us, notice how I kind of highlighted it in a different color, is the part of the shadow in which all light from the light source are blocked. There's no light here. No light. Umbra. Umbra. Dark. The area of partial shadow from a non-point light source, right? It's a real light source. It has a real size to it. Is called the penumbra. A little bit of light. A little bit of light. Right there. And the next thing we're going to talk about is light reflection, probably one of the more important things. We're going to spend a bit of time on this in the next chapter. You can see a book or anything around you, right? You can see this book and other objects around you because light reflects off the surfaces. Incoming light rays travel parallel to one another, and they hit what you're looking at, and they bounce back into your eye. If you see something, then light hit it, and it bounces into your eye. Now, there's a really important thing called regular reflection. See how I put it in a different color? The light rays strike a smooth surface and reflect in the same direction, staying parallel to one another. All the rays are reflected in the same angle, so when these reflected rays reach your eyes, they are almost the same as they were before they reflected. When regular reflection has occurred, you can see an image like this, a mirror, right? If you had an object here, maybe your hand in front of the mirror, the light would leave your hand, bounce off the mirror, and if your eyeball was there, you would see an image of your hand. See how the light rays all keep their pattern? They're all regularly reflected. That's like a mirror. You can see an image. However, even objects that do not reflect an image can still reflect light. For example, although the pages of your book may appear smooth, they are rough enough to cause light to be scattered in many directions. Look, the light rays all came in regularly, but since it's not a smooth surface, one might reflect one way, another will reflect the other way, right? It's hit a rough surface. They don't stay parallel when they reflect. It's scattered, resulting in what we call diffuse reflection. Because light is scattered, you can see the page from almost any angle, but you won't produce an image. You're not going to comb your hair. Well, I'm going to put a piece of white paper in front of my face and use it to comb my hair, or shave, or put makeup on, or both. It's not going to happen. It's too rough. The reflection is diffuse. It's irregular. You don't get the nice pattern like from a mirror. You can put a mirror in front of your face and shave or put on makeup or both, and you'll get a nice image. The pattern of the parallel line remains. All right. All right, kids. So that's it for today. I hope you watched the video because, it had some actual real good examples in there that I can't really produce for you. You've watched this video lesson, then you're going to read the textbook and answer some questions. If you have any questions on anything, if you need any help, please let me know. I'm here to help you. Thank you and have a great day. Bye-bye.